Hello everyone and welcome to St. Andrew's Institute of Technology and Management, Gurgaon, Delhi NCR. St. Andrew's Institute of Technology and Management is the best college in Delhi NCR in entire India. It is among the topmost colleges of the country. It provides 100% placements. It offers a very wide range of courses from BTech, BBA, BCA, and also starting with B Architecture and LLB and MBA. This is the best college that you can get yourself admission into or for your children. This is the fastest growing college in the country. The subject that we shall be taking over here is Principles of Software Engineering. Code is CSE 302F. This is a CSE 6 semester subject. This is in accordance to the syllabus issued by MDU University Rohtak. The topic we shall be taking here are Review Analysis Modeling, which covers data modeling and functional modeling. I, Shalini from CSE department, shall take you forward. Review Analysis Modeling or Analysis Modeling. It uses a combination of text and diagrammatic forms to depict requirements of data, function, behavior in a way that is relatively easy to understand and, more important, straightforward to review for correctness, completeness, and consistency. Okay, now if I ask you a very general question, right? See, and anything, do you understand better with diagrams or you understand better with just plain text? Just think about it. What will be your answer? I understand better with diagrams and so does everybody else. Why? Because diagrams, it leaves an image into your mind and human mind catches image very fast. Right? So its analysis modeling is actually using text along with the diagrams. Right, when you use text along with diagrams, it becomes relatively easier for you also and the other person also. Right, and in the diagrams, you tell everything about the requirement, whatever the data will require, whatever function it is doing, how it is behaving, how the information flow is happening, how the behavior is changing. Everything is being taking place into that only, right? So this is very diagrams are very easy to understand and um, mm, they are very easy to correct also. See, anything which is easy to understand is very easy to correct too, right? Which is all. So they provide you straightforward reviews for correctness, completeness, and consistency because you won't be drawing any component twice, right? If you find any component twice, what will you do? You will just erase that, right? Or cut it and or remove it from there, right? While if it is a static tables or if it is in the form of tables or anything of that, so then the text becomes kind of redundancy is not that much clear if it is not with the help of diagram. In case of images, you can actually find consistency very easily, right? You can find redundancy very easily, so your data is more consistent and more coherent, right? So there are very different techniques that are being adopted by people around the globe, and so a few of them are flow oriented modeling. So flow will tell you how the data objects are transformed by asset to processing functions, right? So flow will tell you how the objects, right, how the entity or the objects are being converted into functions, how are they behaving, how is the flow happening, right? Scenario based modeling, this represent the system from the user's point of view, right? So we say what is the user scenario. Let's see, use case scenarios we call it, na? Suppose if I have a movie ticketing system and I say, so from my point of view, so hey, from a customer's point of view, it should be very easily I should be able to book my tickets, right? Very fast, very simple, very easy to understand, and the payment process also should be very I would say secure also and easy also and like one go, right? So this is very important. And then we have class based modeling. This defines into objects. See, wherever with their classes will use objects, right? We'll make a class, we'll make an object of a class, and then access the data and functions of that class. So these objects, they have their own attributes and they share relationships among them, right? So that's also very important. Then you have behavioral modeling. This depicts the state of classes and impact of event on the states, right? So they depict how the classes are actually getting affected by any event or any state, kind of any kind of I would say any kind of an event or anything which occurs. So how they behave, how the classes behave, whether they change their state from one and they go to the next. So this all takes place. And this is not just not limited in those four. They can have n number, like flow, UML, requirement analysis. So there are n number of things. But broadly looking into the aspect of it, I just we just usually classify it into this way, right? So you're not limited by these four only, right? So we have first requirement modeling. See, before going to data modeling, we need to actually know what is requirement modeling. Requirement modeling is a part of analysis and design, right? Which we already studied in our SDLC when we were doing our models. It is the planning stage of developing a software applications, right? Because you gather the requirement as to, because you want to know as to what exactly you want to do, right? If you are if you are somebody who was kind of a developer, so you want to know actually what the customer requires from me, right? So always it is always in the planning stage of a development process. Requirement focuses on what, not the how, which is also good. Like, what do you want, what do you require? You don't say how do you require, because how is the wherein the implementation will begin and all the designing will be happening and the original process will be going on at that point. So requirement just tells you what is it you want. Okay, this is what you want, fine. So in other words, requirement modeling identifies what requirements the application must meet in order to be successful. So what are the requirements that it needs to be successful? Requirement modeling includes many sub-stages, one of them being data modeling. A use case, simply put, is a primary example of how the software application will be used and what it is expected to do. So once a use case exists, one of the stages that follows will be data modeling. So anything which will be the use case or kind of a scenario based, then data modeling will come into play. So now we come to data modeling. Data modeling is the process of creating a data model, right? Data model for what? For the data to be stored in a database. So it is basically kind of a data model. And what kind of, so this data model is a conceptual representation of data objects, right? So how conceptually the data objects will be placed, what work they'll do, what associations they'll have in between them, what are there various types of them, are there any rules over them, so they will all be taken into account. Data modeling helps in visual representation of data and enforces business rules, right? Regulatory compliance and government policies on the data, which is very correct, because anything would have some rules defined in there. So there'll be business rules about of the company, there'll be regulatory compliance along with the standards, and there'll be government policies on the data, right? So data models ensures consistency in naming conventions, default values, semantics, security, while ensuring quality of the data, right? So it data models always ensures that the data is consistent, and it follows the naming conventions, and it has some default values in it. There is a relationship among them, and it is secure. So this ensures all of these combine to form the quality of the data. If you compromise in any of the situations, ultimately the quality of your data will decrease, right? Which is very very I would say self understood also. So data model emphasizing on what data is needed and how it should be organized instead of what operations need to be performed. This is what we actually discuss, this thing, that what is to be done, right? How is not the key, not the case that you are being interested into. So how it is organized and how what, so this is what we don't need in here. It just needs what data is needed, right? So there are two types of data models, the entity relationship model and the UML model. We shall be coming after in the units, right? So, and there are different types of data model. What are the types? Like conceptual, logical and physical. So what will the conceptual say? So this data model define what the system contains, right? So what my system will contain is actually defined by the conceptual model. So this model is typically created by business stakeholders and data architects. The purpose is to organize, scope and define business concepts and rules, right? So this is typically created by business stakeholders and data architects. Who are the one who are designing it? These are business stakeholders and data architects. And what is the purpose? The purpose is to organize, uh, right, and scope and define business concepts and rules in it. Then we come to logical. So this defines how the system should be implemented regardless of the DBMS, right? So they will tell you that how it is implemented. The conceptual will define like what it will contain, and logical will tell you that how it is being implemented, right? So it is created by data architects and business analysts. The purpose is to develop technical map of rules and data structures. The physical one, this data model describe how the system will be implemented using a specific DBMS system, right? So this will tell you how the system will be implemented and they'll be using a DBMS system. This model is typically created by DBA and developer. So who will be the one developing the physical data models? The DBA and developers. The purpose is actual implementation of the database. See in how it is going. See, the process model and data requirements are giving you the logical data modeling, and the output is a logical data model. So this along with technical requirements and performance requirements is an act input to physical data modeling, which gives you the physical data model. The output is the physical data model. And then along with the business data we and physical data, we actually create the actual data, right? And we update if it is, like we create if it is for the first time, and if it we are updating, then we update it also. So now we comes to conceptual model. The main aim of this model is to establish the entities, their attributes and their relationships. In this data modeling level, there is hardly any detail available of the actual database structure. The three basic tenets of data model are: first, entity. A real world thing is known as an entity. Then we come to attribute. Characteristics or properties of an entity form the attributes. Then we have the relationship, right? The dependency or association between two entities. So what are the three basic tenets of data model? Entity, attribute and relationship. Entity is a real world thing. Attribute is characteristics or properties of an entity. And third is the relationship. Entity is the one which will be representing the kind of object that you are taking in, right? And it will have some characteristics. So all the characteristics will form the attribute of the entity, and it will be dependent on something, or it will be associated with something, that it will be having some relationships with other entity or other kind of units or the other kind of objects. So this is how the conceptual model comprises of. See, if we have customer and product as two entities in this example, so the customer name and name are attributes of the customer entity. So customer entity will combine of the customer number and the name, and the product name and price are attribute of the product entity, right? So sale is the relationship between, so what kind of product we are selling to the customer, and the customer has a name and a number, and similarly the product has a name and it has a price. So the two are, see if I can see in this figure, I have two entities, one is the customer and one is the product. And what are the attributes between them? The customer has two attributes, customer name and customer number, and product has two attributes, product name and product price. And the relationship that the two customer and product share is, it is a sales relationship. The product is sold to the customer, or I can say the customer is buying the product, right? Next we come to logical data model. Logical data model adds further information to the conceptual model elements. It defines the structure of the data element and set the relationship between them, right? So logical model will add the further information to the conceptual model, and it is the one which is defining and setting the relationship between them. The advantage of the logical data model is to provide a foundation to form the base of physical model, right, which we saw in our figure also. Shall I take you backward? See, the logical model was forming the base for the physical data modeling over here in this figure, right, which is the one which is being described in here exactly, right? So how it is, the customer, it has a name which is in string, the customer number is an integer, and product name, and they have a string, and there is like how it is being contained. So the customer name is in the string, the customer number is in the integer, the product name is a string, and the product price is an integer, right? So this is how the structure of the data elements are set the relation. This is how it is being imbibed into it. Then we come to physical data model. A physical data model describes the database specific implementation of the data model. It offers an abstraction of the database and helps generate schema, right? So physical data model is describing the database specific implementation of the data model. So which is the exact, the physical kind of thing is being derived in here. The physical database implemented, the implementation is taking place in over here, and an abstraction of the database, and it is actually helping me generate the schema, right? This is because of the richness of metadata offered by the physical data. So there will be a variety of like metadata is the data about the data. So it comes a huge amount of I would say elaboration of the data comes into here. So this type of data model, it helps to visualize data structures, and it helps to model database column keys, constraints, indexes, triggers, and other RDBMS features, right? So what is the customer, it has a customer name that is into varchar, the customer number which is an integer, the product name which is in varchar, the product price which is an integer, and the primary key acts as the customer number, and here in the product we have product name is the unique key, right? So product name is defining the product uniquely, and this is the customer number is actually being identifying the product uniquely. Now we have advantages and disadvantages. So what are the advantages of data model? See, the main goal the goal of designing data model is to make certain that data objects offered by the functional team are represented accurately. So first you need to check the accuracy of the data, and it should be detailed enough to be used for building the physical data, right? So it gives you accurate kind of the data model has to be accurate, and it should be detailed enough, so that are the characteristics, or I would say the advantages also. The information in the data model can be used for defining the relationship between tables, primary and foreign keys, and stored procedures. Data model helps businesses to communicate within and across organization. Data model helps do documents data mapping in ETL processes. They help to recognize correct sources of data to populate the model. What are the disadvantages? To develop data model, one should know physical data stored characteristics. This is a navigational system. It produces complex application development management, right? It requires knowledge of the biographical truth. So it needs deep amount of knowledge. It is a prerequisite of before drawing a data model, right? Even small changes in the structure require modification in the entire. Even if you make a very small changes, the entire data model has to be changed. And there is no set data manipulation language in DBMS, right? So there's no I would say fixed kind of a norms or a fixed kind of a language that it defines in for the manipulation purpose. Next we come to functional modeling. See, functional modeling gives the process perspective of the object-oriented analysis model and an overview of what the system is supposed to do. See, functional will give you an perspective of the object-oriented analysis model and an overview of what the system is supposed to do. It defines the function of the internal processes in the system with the aid of data flow diagram. So, who will be the one doing it? Data flow diagram. It depicts the functional derivation of the data values without indicating how they are derived, when they are computed, and why they need to be computed, right? So it does not go with how they are derived or why they need to be computed, but it depicts just the functional derivation of the data, right? So what the system is supposed to do, not how it is supposed to do and why it is supposed to do, right? Only what it is concerned only with what, not the how. And what are it is done with the help of DFDs, that is data flow diagrams, right? So you need to remember that the functional modeling, it sees what it is supposed to do, not how it is supposed to do, and it is done with the help of data flow diagrams. See, Rambo defined DFT as a data flow diagram is a graph which shows the flow of data values from their sources in objects through processes that transform them to their destinations on other objects, right? So this is the formal definition from Rambo. So what it formally defined data flow diagram. So he formally, when he started with DFDs, so he was the one who defined it like this. So there are four parts of DFD. First is the process, then we have data flow, we have actors, and last we have data stores. And there are other parts like constraints and control flows. So we first come to processes. So processes are a computational activity that transform data values. A whole system can be visualized as a high level process. So processes are computational activities that are actually transforming data value. A process is represented as an ellipse with its name written inside it. So we draw an ellipse, and inside the ellipse we write the name of that process, right? And it will have fixed number of input and fixed number of output. Then we have data flow diagrams. Data flow represent the flow of data between two processes. So how the flow of the data shall be taking place between two processes defined by data flow, like the data flow will define it. And it could be between an actor and a process, or between data store and a process, right? So process or actor, or process or storage, right? So a data flow denotes the value of a data item at some point of the computation. So at that point, what will be that the value of that data, and this is unchanged in a DFD. You cannot change it, like it is not changing over there. So at that particular position the data is fixed. At some other it might change, but at that particular location, for that particular process location, it is fixed. So it is represented by a directed arrow, or an arc, we can say a directed arc, and it has a name on contained on that arrow, just like the process may entity contains the name. Then we have actors. So actors are active objects that interact with the system by either producing data and inputting them to the system. So what will my actors do? So they will interacting with the system, and they will be producing data and input them to the system, and right, so they will produce this data and it will act as an input to the system, or it will consume data produced by the system, right? So he is actually say the consumption he is doing, right? Or either he is producing something. So data is the producer or the consumer of the data, right? And it is an active entity. So actors serve as source and sink of the data, right? Which is I was talking about, the producer or the consumer. An actor is represented by a rectangle, and actors are connected to the input and output and lie on the boundary of DFD. So they will be lying on the boundary of the DFD. Then we have data stores. Data stores are the passive objects that act as a repository of data. So what will have this data stores will contain, it will be a repository of data. Unlike actors, they cannot perform any operations, right? So data stores are not active, they are just for storage purpose. They don't have any active participations into it. And what are they used to store? They are used to store data and retrieve the stored data. They represent a data structure, a disk file or a table in a database. A data store is represented by two parallel lines containing the name of the data store, right? So what will be my name of the data store will contain the, it will be inside two parallel lines will be there, like open ended, they will not be closed, and inside them there will be a, and these will not be directed lines, normal finite lines, parallel lines, and they will contain the name of the data store, right? And they should, at least one of the process they need to be connected to. Next we come to constraints. So constraints specify the conditions or restrictions that need to be satisfied over time, right? So this constraints mean it has a limitation that it has to be done, right? So within that kind of a time period it has to be done. So these are constraints on the system, right? From the general name, the like what is the general meaning of constraints in general English language, we can understand the meaning of it, right? So it is like constraint, like I have some limitation, right? So it has to, like I have to specify that, or I have to follow that, or I have to be bound by that for that particular moment or duration of time, right? So they allow adding new rules or modifying existing ones. A constraint is rendered as a string within braces, right? So within braces you will be writing your constraints. So control flow, a process may be associated with a certain boolean value, right? And it is evaluated only if the value is true, though it is not a direct input to the process. Hmm. So boolean will this will only take place if the value comes out to be true. In case if it is false, it will not be getting executed. So these are boolean values are called the control flows. The control flows are represented by dotted arcs, right? From the process producing the boolean value to the process controlled by them. So whoever is the source of those boolean values to the one that they are affecting, it will have dotted lines to show the control flow. That okay, this this entity or this process is containing the other process, controlling the process with the help of this relationship, this kind of a when this constraint or I would say this becomes true or this becomes false. So there's example. So the following figure, it shows the expansion of process a certain graphs. It has two processes in it. Find total sales and decide the type of coin. So find total sales in one and deciding the type of gift coin that it has to be is again one. So what it does, the find total sales, it computes the yearly total sales producing to each customer and records the data. Where it is recording, see what is the database over here, total sales, it's in parallels, right? So find total sales and decide of gift points, these are the processes, and all these arrows are being and the data it is being containing into it, and then this total sales, it has this, it's getting stored in there. And after this, actually the total sales that is being calculated is it acts as input for this process, right? And then it is giving the gift details, that what kind of gift we will get, what kind of gift. So this is a example of a DFT. So we are done with this. We have a few questions like what is analysis modeling, though this is rarely asked, but still it's in your syllabus, so I wrote it down. What is data modeling? Yes, it does come. What is functional modeling? Yes, it is very important. What are data flow diagrams, or explain DFDs? He might tell you DFD or he might tell you data flow diagram. You should not get confused, like, and this is very very important. Data flow diagrams are very very highly important for you to remember it. So I hope this you understood everything in the video, and if in case of doubt, please feel free to contact. Thank you, have a great day.